Hello everyone, thank you all for listening to prior educational videos from the Public Health Academy. Today I'll be introducing the case control study design and reintroducing the measures of association known as the odds ratio. If you're not familiar with the odds ratio, kindly watch the video titled How to Collect an Odds Ratio. Below are the learning objectives that will be covered throughout the mini lecture. Characteristics of a case control study design, when to use case control studies, a 2x2 table in which I would explain how to um, illustrate that through a case control study, um, learn how to calculate and interpret an odds ratio, as well as one practice problem along with the solution. In case control studies, we select individuals based on disease status. And when I mean by disease status, we look at different health ailments. That can be asthma, heart disease, type 2 diabetes. An example is posted on the slide and I'll read out loud. Investigators conducted a case control study that examined the relationship between cigarette smoking and chronic obstructive pulmonary disease. 10,000 cases were selected from a disease registry. In addition, 5,000 controls were also included in the study. Important terminology, such as the ones in which I would state cases, controls, will be discussed on the next slide. Another important terminology that is important when discussing the case control study are cases and controls. Cases are individuals, a population or study group who have a particular disease, illness, or health condition. There are different sources in which we can select cases. These include individual physician diagnosis, registries such as birth, death, or cancer, clinical records, and surveys taken from a general population. The next one is controls. Controls are individuals, a population or study group that do not have a particular disease. They also serve as a comparison group and must come from the same source population as the cases. And important terminology that is not posted on the slide is source population. A source population is a population from which your study subjects are drawn. An example of this is the following. Investigators conducted a case control study that examined the relationship between smoking and chronic obstructive pulmonary disease. A sample size of 15,000 nurses were selected from Boston, Massachusetts. So in this particular example, the source population is 15,000 nurses, specifically selected from Boston, Massachusetts. Next, we have the case control study. There are a set of requirements when researchers want to implement a case control study. These include the following. The disease is rare, such as cystic fibrosis, Huntington disease. The disease has a long induction and latent period. The population is dynamic in terms of people are moving in and out of the geographic location, and little is known about the disease. Investigators can evaluate more than one hypothesis, then with that hypothesis, generate a research question based on literature review, and then also implement their case control study based on prior research papers and also research studies that have been implemented based on their outcome and exposure. Next, we have the case control study design. So for the case control study design, we have a defined population. That defined population can be nurses, it can be policemen, it could be high school students, it could be college students, it could be professors. Then you have controls and cases. As I stated in prior lectures, controls are individuals who do not have the disease, and cases are individuals who have the disease. Then you have their exposure status in terms of individuals who were exposed to a certain risk factor and individuals who were not exposed to it, which are known as the unexposed group. Next, we have the 2x2 table. And this, as you can see, is that you have the cases and the controls. The cases are individuals who have the health ailment. Then we have the control group in terms of people who do not have the health ailment. And then you have these four important letters. So you have A, B, C, and D. A represents individuals who were exposed to a certain risk factor and developed the health disease. Then you have the next letter B in terms of individuals who were exposed to the risk factor and did not develop the health ailment. Then you have letter C. Letter C represents individuals who developed the health ailment but were not exposed to that specific risk factor. And then you also have the letter D in terms of you have the control group in terms of they did not develop the health ailment and were not exposed to the risk factor. With these important letters, we can create With these important letters, we can create the odds ratio calculation. An odds ratio, as I stated before in the definition, is a measure of association that is used to compare the odds of developing an illness in the exposed group to that of the unexposed group. And that is A times D divided by B times C. And we use this important formula to put into practice for the practice problem. For practice problem number 1, I'll read out loud. Investigators conducted a case control study that examined the relationship between cigarette smoking and chronic obstructive pulmonary disease. 10,000 cases were selected from a disease registry. In addition, 5,000 controls were also included in the study. Among the 10,000 cases, only 500 were exposed to cigarette smoking. Furthermore, 200 controls were exposed to cigarette smoking. Create a 2x2 table and create the odds ratio. So with this practice problem, we have to extract important information, and I'll explain. So the first number is the 10,000 cases. The second number is 500 who were exposed to cigarette smoking. Then important information, of course, you need to put into consideration is the 5,000 controls that were included in the study and the 200 controls who were exposed to cigarette smoking. And we'll put all these important numbers in the table, and it will also include some subtraction. So for the practice problem number 1, this is a 2x2 table that was created. So first off, we have cases. And I stated in the previous slide that we have 10,000 cases. So with the 10,000, we have to subtract the 500 cases who were exposed to cigarette smoking. So that leaves us with 9,500. Next, we have the control section. And in total, that is 5,000. And then from the 5,000, we had to subtract 200. And that gives us 4,800 individuals who were not exposed to cigarette smoking and who were also controls. And with this important numbers, we can use that to calculate the odds ratio. So the odds ratio is A times D divided by B times C. So the first part, you can do a quick plug and chug. That's 500 times 4,800, and that gives you 2,400,000. Then the last part, B times C, is 200 times 9,500, and that gives you 1,900,000, and that gives you 1.26 as the odds ratio. I also forgot to mention that the 1.26, yes, is an odds ratio, but it's a specific terminology called the disease odds ratio because study participants are selected based on disease status. With that said, thank you all for listening to this mini lecture on case control studies, part 1. In future educational videos, I will explain to you much more important characteristics that pertains to the case control study.